Welcome back, and I'm welcoming you to another graph problem, or how to work out solutions from a graph, or how to understand or interpret these graphs of motion. Let's have a look at this one. This one is a velocity versus time graph. And here I have got a graph again starting at, we're looking at an object that is already at motion, in a motion. So at time 0, it is already moving at 2 meters per second. So it is moving, we're observing it, but in that movement, we see it is increasing its velocity from 2 meters per second. Up to that point, it is now at 5 meters per second. But we see here, it is leveling up there from seconds 3 to 5. So for 2 seconds there, we see no change in the velocity. Now, what does that mean? It doesn't mean that the object has stopped moving. What it means is that the object here is moving with constant velocity. It's moving with constant velocity v. But here, from there to there, we are not seeing a constant velocity. We're seeing this object increasing its velocity, increasing and increasing it from 2 meters per second to 5 meters per second in about 3 seconds. Okay, so here, what do we see here? The object is accelerating, because change in velocity means there is acceleration. Object is accelerating, okay, and if you check here, from 2 meters per second, it accelerated to 5 meters per second in 3 seconds. Okay, so from 1 to 3 seconds, we see it accelerating that way. Now, another thing, apart from unpacking the graph itself, another thing that we can do or see from this graph is that if we were to calculate the area enclosed by the graph, that's the area between the x-axis or the time axis and the graph itself, we will find what we call the displacement of the object after whichever time. And how do we do that? If you look at this graph here, we do that by finding the area enclosed by the graph, okay? The area enclosed by the graph. And how do we find the area? If you look at the area between the graph and the time axis, we have got that part there. This is a right-angled triangle, so that's a right angle there. So we can find the area of this, which is a half times base times height. Again, there is this part there, okay, which is also underneath the graph. The area here is given by what? Length times breadth, because we've got a rectangle there. And another thing, remember, is the whole area under the graph. So there is also this whole area here under the graph, between the graph and the time axis. So again here, area is length times breadth. So we've got area 1, area 2, area 3. If we add all those areas, we'll see or find out how far the object moved within the time that we have been observing it. That's 5 seconds. So let's work it out. I believe we have some time to can do that. If you work this out here, this will be half. What is the base of your triangle? The base is this one. It's half 3 times the height. The height of this triangle is from there to there, so that is 1, 2, 3. Okay, so from 2 to 5 is actually 5 minus 3, and that is 3. So 5 minus 2, that is 3. So half 3 times 3, so this is 3 times 3 is 9 divided by 2. This is 4,5 meters. You come to area 2. You look at this, it says L times B. What is your length here? The length is, you can choose any, okay, because at the end of the day, you're just multiplying. This to there is what? It's 2. And then from there to there is what? It's 3. So let me say my length is 3 times from here to there, which is from there to there, it's 2. And therefore, area 2 is equal to 6 meters. You come to area 3. Area 3 is this whole area, So area 3, length times breadth, or immediately I can see my length is this one here. So it's what? It's 5 times my breadth is from there to there, and that is 2, and that gives me 10 meters. Now, if I add all these areas enclosed by this graph, that is the area or the section of the graph between the graph and the time axis, if I add that, I get the total displacement of the object. How do I do that? So total displacement, delta x, total of this object will be area 1 plus area 2 plus area 3. Okay, so that will be equal to 4,5 plus 6 plus 10. And what we have here, this is 10,5 plus 10, that gives you 20,5 meters. Okay, now here we are. We have interpreted the graph. We have also unpacked what the graph says to us. Now, what can we conclude? One, we conclude here that if we have got a velocity time graph, we will find, so velocity time graph gives what we call the displacement of the object. And when we do something else to it, you'll see we may also find the acceleration. But for now, let's rest it there. Let's meet in the next section.